Okay, so we have learned how to solve through the process of graphing. Graphing is not always the best, however. First of all, if your lines are not in slope-intercept form and you have to go through the work of trying to make an XY table and plot them, that can be very time-consuming. Also, what do you do if your lines do not cross at integers, at whole numbers, and instead they're crossing at decimals and fractions like 1/3? You can't pick that out on the graph, so you do want to be able to solve algebraically, and there are two methods. The first being substitution, which we're going to work on. So let's say you have a system where the first one is y equals 3x plus 1, and the second is y equals 7. Now, this would just be a horizontal line. But if I said, folks, here's an equation, and I'm telling you that y is 7, you would easily say, okay, Mrs. Lang, I'm going to substitute 7 in for y in that top equation, and I'm going to solve that, which is exactly what we're going to do. That's why it's substitution. So we're going to plug 7 in for y, and then we can easily solve for x. Subtract 1, so 3x equals 6, divide by 3, x equals 2. So our solution is x equals 2, and we already knew that y was 7, so we don't have to plug back in and solve for y. That also means if I were to graph these, they would cross at the coordinate point, 2, 7. Okay, I'm not graphing, I'm solving algebraically, but if I did graph them, they'd cross at that point. X is 2, y is 7. And of course, we can plug back in and check our answer. 3 times 2 plus 1 is 7. So keeping this in mind, what if I gave you this instead? So we're still going to do y equals 3x plus 1, but instead of y equals 7, it's going to be y equals 5x minus 13. We can still solve this. We can still substitute. So just like I took what this y equaled and plugged it into that y, I'm going to do that here. Yes, that was a single number. Here I'm going to plug an entire expression in. So I'm still going to take what y equals and I'm going to plug it in to that y. So what I have is 5x minus 13 equals 3x plus 1. And what we have created is a variable on each side situation, which we have solved before. So subtract 3x. I have 2x minus 13 equals 1. Add 13. 2x equals 14. Divide by 2. X equals 7. So in this problem, our x is equal to 7. Now, we're not done like we were over there. Over there, we found that x was equal to 2, but we already knew what y was. Here, we do not know what y is. We need both x and y. We only have x. So now that I've solved for x, I'm going to substitute that 7 in to find y. So since I know what x is, I can substitute 7 in for x here to find y, or here. It doesn't matter which one I choose. I'm going to go ahead and choose the top one. So I know that y is equal to 3. Instead of 3 times x, I'm going to substitute 7 in plus 1. This is pretty simple. I don't even have to solve. I just have to do the math. 3 times 7 is 21, plus 1 is 22. So y equals 22. So this would cross at the coordinate point 722 if I graphed it. This is one reason we want to do it algebraically. You do not want to graph out to 22. That's going to take you a while. Okay, now I'm going to check. Since I plugged into that equation, I'm going to go ahead and check with this equation. Does 22 equal 5 times 7 minus 13? 5 times 7 is 35. 35 minus 13 is in fact 22. So it checks, and I am good to go. So that's one form of substitution where you're given two y equals and you plug one in for the other. There is another kind of substitution. So instead of a y equals equation, if I give you 2x plus 3y equals -1, and I tell you that y equals -3. So we are back to me giving you the y, and we just have to find the x. Again, I'm going to take this and I'm going to substitute it in for y up there. So it's going to become 2x plus 3 times negative 3. So I'm plugging negative 3 in for y because that's what y is equal to, equals negative 1. Now I'm going to simplify this. I have to do this math. So 2x plus 3 times negative 3 is negative 9 equals negative 1. Now I can solve this equation for x. So because that's negative, I'm going to add 9 to each side. 2x equals 8. I'm going to divide by 2. I don't know if you can see this. X equals 4. Okay? So I know x equals 4. And I already knew what y was, so y equals negative 3. These would cross at the coordinate point for negative 3. And of course, I can check my answer. Does 2 times 4 plus 3 times negative 3 give me negative 1? 8 plus negative 9 is in fact negative 1, so it does check. So again, I substituted in for y and then solved for x. So, put that back up there. That was y equals negative 3. I'm going to have a similar problem over here, but again, I'm not just going to have y equals a number. So if I have 2x plus 3y equals negative 1 again, but this time y does not equal negative 3, y equals 2x minus 3. So just like I did here, and I took negative 3 and substituted it in for y, I'm going to take this entire expression and substitute it in for y. Now I find the easiest way to do this is to rewrite this kind of leaving a blank. So over here, it would look like this, where I'm going to leave a blank for y because I'm substituting in for y. What is y? Negative 3, so I can plug it in. Same thing here. I'm going to say 2x plus 3, and I'm going to leave a blank. Notice I left a little bigger blank because it's an entire expression, equals negative 1. Now what do I fill that blank in with? What y is equal to, which is 2x minus 3. We've done problems like this. I am going to have to simplify before I can solve. So I have to do distributive property first. 3 times 2x is 6x. 3 times 3 is 9. I can still simplify. I can add my like terms. So I will have 8x minus 9 equals negative 1. Now I can solve this equation for x. Add 9. 8x, negative 1 plus 9 is 8. So if I divide by 8, x equals 1. Okay, so I have that x equals 1. But again, I still have to find y. I don't know what y is, and I need both points. So, just like before, now that I know what x equals, I am going to take x and substitute it back in for x here or here. I can use either equation, it doesn't matter. I don't know about you, but I think it looks a lot simpler to plug x into this equation. So I'm going to plug 1 in for x. So I have y equals 2 times 1 minus 3. 2 times 1 is 2, minus 3 is negative 1. So y equals negative 1. So with substitution, most of the time there is a lot of work finding that first variable, which is usually x. Usually we substitute in for y and find x. It could be the other way. You could substitute in for x and find y. Either way, once you find the first variable, getting the second variable is usually not even a solving process. It's just plugging in and evaluating. Okay, that means that's my answer then. 1, negative 1. So does it take a lot of work and a lot of paper? Yes. Is it super difficult? No, because everything on here we've done before. Okay, let's try one more kind of from the beginning. Okay, so we're going to have y equals 4x minus 1 and 2x plus 2y equals 3. Okay, so I have a y equals. So I'm going to take what y equals and I'm going to substitute it in for y in the other equation. So what I'm going to do is I'm going to rewrite this equation, leaving a big blank where the y is, because that's what I'm going to take out I'm going to replace it with that. So I'm going to leave a blank big enough to put an entire expression in. Everything else is the same. The 2x, the plus, the 2 times, and then the equals 3. Those are all the same. Now what am I going to plug in for y? This expression, 4x minus 1. And by leaving a blank there with parentheses, I'm already set myself up for a distributive property and didn't have to worry about that. The parentheses just make sure that I do that multiplication. Now I will distribute. 2 times 4 is 8x minus 2 times 1 is 2. I'm going to add my like terms. 2 plus 8 is 10. So I have 10x minus 2 equals 3. Now I can solve this equation. Add 2. 10x equals 5. Divide by 10, x equals a half. 5/10 is 1/2 or 0. Whoops. It's 1/2 or 0.5. So I have found x. X is a half. However, I still need to find y. So what I'm going to do is take 1/2 and I can plug it in for x here in this equation or this equation. Again, that equation is going to be a lot easier. So I have y equals, instead of 4 times x, it's going to be 4 times 1/2 minus 1. Half of 4 is 2, and 2 minus 1 is 1. So y equals 1. And that is how you can solve. So again, these would cross at the coordinate point 1/2, 1. This is another reason why we want to be able to do this algebraically and not just graphing, because A, it would take a little bit of work to graph that equation, and B, this would be crossing at a fraction. It would not cross at an exact integer. Okay, so substitution. Substitute in, leave your blank, substitute in. You're going to have to do some simplifying and some solving. Make sure that you don't stop at getting the first variable and you do plug back in to get the second variable.